Hey everybody, welcome back to our second video on graphing motion. Two videos, same polo shirt, because graphing motion has a lot of information, a lot of stuff to go over. In this video, we're going over one new thing, at least something that wasn't talked about in the last video, but don't worry, it's not quite as tough as how we ended the last video with that sketching motion graphs. It's not too bad. But then the second part of the video is an example set of questions, meaning I'll have several questions, and the idea being you pause, you try them on your own, and then you could check your answers by continuing to watch the video, or if you're stuck anywhere, listen to my solutions. But that's the second half. Let's go ahead and first start with the one thing that we haven't yet covered, and that is looking at the area under the curve. Now, in our last video, we spent a lot of time looking at slopes, right? And it turned out that looking at the slope of a line segment in a graph would give you information. There is something else we can look at in a graph. We probably did something similar in like a math class, maybe a geometry class or an algebra class. I have this graph here, and I have this red line, that's the line for our graph, and we could look at and we could calculate the area under the curve. That's what it says right at the top of this slide here. And looking at the area might also give us information. Let's see how. Okay, here there's a question. Okay, we're going to learn by looking at a scenario. It says a bus starts at rest and it moves to create this graph. Okay, it's kind of funny this example because it looks like the bus goes from 0 meters per second. It's a velocity graph all the way up to 50 meters per second, and that's funny because that's about like 110 miles per hour. So this bus driver is flooring it, but whatever. Okay, this is the graph that this bus driver creates as it's traveling along. Now, it's a velocity graph. The question is asking what is the displacement of the bus in section A. Section A is right here. It's these first two seconds, I should say. This part right here, this first kind of straight diagonal line. Okay, what is the displacement? Now, at first, that's maybe a weird question because we haven't learned that, at least not from the last video. We learned that finding the slope of this line would give us, do you remember? It's a velocity graph. What would the slope of this line give us? It doesn't give us displacement, it gives us acceleration. How would we figure out the displacement? Well, let's arrive at that idea by doing what the top of this slide is saying. Let's calculate, just kind of for fun, the area under the curve. I mean by that the area between the line, this red segment right here, and the x-axis. I'm going to kind of shade it in to show you what I mean. Let's find the area of this section. It kind of makes a triangle, right? From 0 to 2, this section, it makes this triangle. So what's the area? Let's see. It's a triangle, so what's the area of a triangle? Do you remember? It's 1/2 base times height. Okay? So in this example, it's 1/2. What's the base? What's the base value? Well, it's 2, right? The base is in the x-axis, that's time, that's seconds. So the base here is 2 seconds. That seconds is going to be important for understanding this, so don't leave that out. What's the height? What's the height of this triangle? It looks like it goes up to 30, but not just 30 meters per second, because that's the velocity, 30 meters per second. Well, let's do a little multiplication. I'll keep that 1/2 here. 2 times 30 is, of course, 60. But something interesting happens with these units. I'm never going to directly test you on what happens with unit analysis, but I have seconds, and then I have this fraction that has seconds in the bottom. It causes those seconds to cancel out. You do this a lot of chemistry in chemistry class. If you haven't done that, well, that's okay. But it turns out that the seconds kind of cancel, and you're left with just this m, this meters on top. When you do this multiplication, you're left with just meters. That's your unit. And if I finish this math problem, that means the answer, finding the area under the curve, gives me an answer of 30 meters. What does that mean? This bus had a displacement. It traveled 30 meters. This is why finding the area is also powerful for graphs. Finding the slope can give you information, but also finding the area under the curve can give you information as well. In this case right here, the area under the curve can give you data also. If it's a velocity graph, finding the area, meters per second multiplied by seconds, that's going to give you meters. That's displacement. We're not going to do it in this video, but you could figure out pretty easily what finding the area under an acceleration graph would give you, okay? As long as you can kind of think about these axes, you're always doing base times height. Whether it's a triangle, or if I did section B, that would be like a square right here. Even if it's like a trapezoid, all these areas for all these geometric shapes, we're not going to do curves, not going to do like curvy lines. They're always going to be some version of base times height, which means you could figure out certain values like the displacement from a velocity graph by looking at the area under the curve. Okay, so that's the other kind of new thing. Not too bad, but you're doing a little bit of geometry. Now, a lot of students often get confused, like if I ask for section C, what would the area be for section C? Now, in section C, this bus is moving fast, right, up to 50. Don't just do this. That is not the area under the curve for section C. It's this whole thing. It's always from like the line and the origin. So this would be your geometric shape right here. That might be a little tougher. You have kind of a triangle and a square. But don't just do the little triangle part. It would be the whole thing from the line and the x-axis. Okay? Now, let's move on to part 2. Now, for this part, it's just a practice problem. It's several questions. I recommend when I show you the next slide, you hit pause, you try each letter, and then just hit play, and then we'll go over each of the answers. Okay? That's the idea. So, in this example, we have a jogger, that's with a diagram right here, and the jogger is moving, and we create this velocity graph that's shown. Okay, I have 6 different questions, A through F. I'm going to move my screen, sorry about that, I'm kind of in the way right here. Again, hit pause, try this on your own, and then hit play, and we'll go over each one of them. Okay, go ahead. I'm not actually going to wait. Hopefully you hit pause and you try them out. Let's go over each of these 6 quickly so you can check your answers and or get some help if you're not sure how to answer these. I've broken it up. I'm going to do 3 on this slide and then 3 on the next slide, okay? For part A, it's asking, when is the jogger's velocity negative? Let's look at this graph. When is the jogger's velocity negative? I'm answering part A. It's a velocity graph. So the y values, those are the velocity values. So whenever you have the y values being negative, that's when the velocity is negative. So when is this jogger having a negative velocity? Well, up here, this is all positive, so nowhere here, nowhere over here. These are all positive velocities, all positive y values. They have a negative velocity starting right at this spot. Looks to be at, what, 3. So from 3 seconds going to about, let's see, still negative, negative here, negative here, negative here. The graph isn't perfect, so let's see, it looks like it's about 11, about 12, and maybe a little more than 12, but whatever. Okay, around 12 seconds. Now, in this class, gang, we're never going to worry about bound or unbound. Okay, if you've heard those in math class, don't worry. We're not going to worry about it. If you said between 3 and 12 seconds, beautiful. That's the right answer. Okay, if it's a velocity graph, the velocity will be negative when those y values are negative. I'm going to change colors. Okay, let's go on and answer letter B. Letter B. What is the jogger's displacement from 0 to 3 seconds? This is just like what we just talked about. 3 seconds is right here. Right here is 3 seconds. 3 seconds. It's a velocity graph. I want the displacement. So what do I want? The area under the curve. The area in this case is a triangle again, just like before. So 1/2 base times height. What is the base? It's 3 seconds. So 1/2 times 3 seconds. What's the height? It goes up to 3 meters per second. So a bit of a math problem. Now 3 times 3 is 9. 9 times 1/2, that's 4.5, and that's meters. Okay, just like the last slide. So the displacement from 0 to 3, it's that area under the curve. That is 4.5. Okay, next one. I'm going to change colors again. I'm going to go to red. C. Right down here. What is the jogger's acceleration at 4 seconds? Okay, the jogger's acceleration at 4 seconds. 4 seconds is right here. That's at 4 seconds. Now, man, this is a velocity graph. So -1, that's the velocity. The area under the curve, that's the displacement. How do I figure out the acceleration? I look at The slope. Oh my goodness. Notice, from the first 0 to 5 seconds, the slope is constant and negative. The acceleration is constant and negative. So if I can find the slope of this line, well, that would be the acceleration. So the acceleration is equal to the slope. The slope from 0 to 4 seconds, well, that's going to be rise over run. Okay, now the slope is constant. I could do this whole thing, but I'll go from 0 to 4. So from 0 to 4 seconds, let's look at the slope. What's the rise from 0 to 4? I'm starting here, negative to 3. That's a rise of, well, 4, but I'm actually going down. So the rise is actually negative 4. What's the run? 1, 2, 3, 4. The run is 4. So what's the slope? That's negative 1. That's the acceleration. Everywhere along this line, from 0 seconds, 1 second, 2 seconds, 3 seconds, 4 seconds, and 5 seconds, the acceleration is a constant value of negative 1. That's the answer for part C. Okay, let's go through the second 3 questions. All right, I'm going to go back to blue. Letter D. Letter D says, when is the jogger speeding up? When is the jogger speeding up? Remember, you're going faster and faster when you have velocity and acceleration having the same positive or negative sign, the same sign. If both are positive, speeding up. If both are negative, speeding up. You could also just kind of reason it out by looking at the graph and looking at when you're getting like further away from 0 meters per second, either in the positive or in the negative. So there are several answers. There are several time segments. First, when is the jogger obviously speeding up? Right here. Okay, when they're going from, what is that? So here's 11, about 12. So from about 12 seconds to about 13 seconds, they're clearly speeding up. They're going from 0 to, what is this value? About 2 meters per second. Or the acceleration, the slope is positive, and the values of that y-axis are positive. So speeding up. When else? This section right here, from 15 to 19 seconds. 15 seconds to 19 seconds. They are speeding up for the same reason. Okay, again, you're getting farther away. You're getting more and more velocity. Your velocity is getting more and more positive. That's speeding up. Or positive slope, positive acceleration, as the values of the velocity are positive. Both positive, speeding up. There's one more. Ooh, maybe you missed one. You are also speeding up, or the jogger is also speeding up right here. From a time of 3 seconds to a time of, let's look right here, time of 5 seconds right here. Now, how is that? The velocity is negative. How could you be speeding up? Well, they're also accelerating in the negative direction. Here, the person is going faster and faster and faster in the opposite direction. That's speeding up too. Remember, the velocity is getting more and more negative, but the acceleration, because the slope is negative. So it's also right there. Oh, on my quiz or on my test, I'm going to get some of you. Some of you are going to miss that one. That is also where they're speeding up. Okay, let's do letter E. Oh man, we're just about done. Letter E is saying if the jogger started at x equals 0, okay, maybe they started at their home. We'll say that's their starting point. Okay, when approximately are they first back at that starting point? So this is kind of a tough question and not really a math question, all right? I'm actually not going to do any calculations here. You could prove it, but I'm not going to, because it says the word approximately. Okay, it's asking when they first return to their starting point. What does that mean in a physics sense? If you return to where you started, that means your displacement is 0. So this question is really asking, and it's a toughie, maybe the toughest on here. When does the jogger first get back to their starting point? When do they first go back to having a displacement of 0? All right. Obviously, the jogger starts off and they're running away from their house at some velocity. But if they come back to their house, maybe because they have a negative velocity, well, that would mean they're going back in the direction they originally came from. You may have a displacement of 0. So this is actually a question all about displacement. What determines displacement in a velocity graph? Oh man, we just went over it. The area under the curve. So in the beginning, the jogger starts out with some positive velocity, and some positive displacement. Again, I'm not going to do any math here. I don't have to. It says approximately. It doesn't say calculate. So in the beginning, from this 0 to 3 seconds, they have some positive displacement. Well, I would get back to a 0 displacement if I end up with a negative displacement after this fact. After these 3 seconds, notice what the jogger is doing. Now they have a negative area under the curve. Yes, this area under the curve is negative. You could think of it as it has a now negative height, right? Now the height of this triangle is -2. So now the area under the curve is a bit negative. And when these two things kind of cancel each other out, when I have the same positive and negative, that would of course mean I have a 0 displacement. So when is that happening approximately? Well, I don't know. I have like this triangle right here. Maybe I approximately have that same opposite displacement, maybe like around here. I'm just kind of eyeballing it. So maybe around 6 or 7 seconds. That's what I'm going to say, around 6 or 7 seconds. That's when approximately this positive area is evening out with this negative area. I believe if you do the math, and you could do it if you wanted, you get a time of 6.25 seconds, because I think I've done that before in a past video. Okay, but you didn't have to. You didn't have to do that for this. If you were like, well, it looks like it's about 6 or about 7, nice. I take that as full points. Okay, last one, letter F. All right, letter F is asking, at the end of their journey from 0 all the way to 20 seconds, does the jogger have a positive or negative displacement? Okay, now it's asking about displacement. So what do I look for? The area under the curve. This question is asking after all these 20 seconds, or I guess it's actually 19 seconds because that's when the graph ends. After these 19 seconds, do I have a positive area, meaning it's above the x-axis, like up here? Or do I have a negative area below the x-axis, like something like down here? Which seems more? Does the jogger mostly have a positive area or a negative area? The answer is positive. At the end of their run, they end up with a positive displacement. Just because, again, just kind of by eyeballing it. You could prove it mathematically. I'm not going to. You could if you really wanted to. Here's the positive. I'm going to do the positive in blue. Like this. Oh man, okay, coloring in, fun times. And I'm going to do the negative in yellow, like this. Just by eyeballing it, man, okay, it kind of evens out at around those 6 seconds, but look at all this big positive area towards the end. Looks like at the end of this run, there's more positive area under the curve, more positive displacement. Okay, I know this was kind of a longer video, but hopefully it's helpful either to watch this as you're learning or practicing or as a review. But those were 6 questions and 6 ways to analyze our graphs, looking at slopes at times, the values at times, and also the areas under the curve. That's it. Thanks a lot for watching.